Alright guys, in this video we are going to do some hydration analysis problems. We'll talk about what is a hydrate, how do we solve these problems, and some example questions. So what is a hydrate? A hydrate is just a molecule that absorbs water. Kind of think of it like hydration, right? You got to hydrate yourself. You need to take in water. Okay, here's a good example, copper sulfate. Copper sulfate can attach water molecules towards itself. So let's say, I'm not going to really draw it, but here's copper sulfate. Okay, and then we have water molecules that like to attach themselves to the copper sulfate. Okay, now the question is, we have this N here. This N tells me how many water molecules actually attaches itself to copper sulfate, because it's not infinite. There is a set amount of water that attaches itself to the copper sulfate or hydrates. So for like here, I drew 4 of them, so it would be 4 H2O. Okay, a lot of analysis or hydration or hydrate analysis questions is figuring out how many moles of water actually attaches itself to the hydrate. So once again, copper sulfate would be the hydrate, and we're trying to figure out how many water molecules will attach itself to it. Okay, so like here's an kind of like an equation right here for copper sulfate with water, and here it is what it looks like. Oops, I'm drawing. This is kind of what it looks like when it is hydrated. Okay, notice it's called pentahydrate because there are 5 water molecules attached to it. It's this nice blue color. And right here it's anhydrous. That means it's without water. You can see it's like this white powdery mixture or whatever you want to call this compound. So this is kind of just differentiating the two, and they change their properties. They change the way they look, the color, everything. So kind of a cool example. All right, so what's the purpose of hydration analysis? Hydration analysis is experimental data to determine the number of moles of water that is attached to the hydrate. So like I said, we're just trying to figure out that N. What is that N? So here is a made-up question that I did. When a hydrate has water attached to it, the mass of the whole molecule can be determined. So we're going to determine in step 1 the mass of the whole hydrate, including the water. Let's assume we weigh a hydrate of copper sulfate with N amount of water, and it weighs 250 grams. Well, in the laboratory, what we're going to do is we are going to dehydrate the hydrate. So we're going to heat the hydrate to remove all of that water. It's now dehydrated. And we'll weigh the hydrate without the water. Let's assume we weigh the dehydrated hydrate molecule and it weighs 160 grams. Well, if the copper sulfate is now 160 grams, we can determine that there was 90 grams of water that got heated away, or what is it, evaporated. Okay, so now we're going to convert moles of the hydrate and water, or moles to water. I have 160 grams of copper sulfate, and I have 90 grams of water. Okay, I'm going to convert it to moles. I'm going to use my train tracks. For every 1 mole of copper sulfate, the molar mass is given to me, and it's 160. I made the numbers really nice. So I have 1 mole of copper sulfate. Do the same thing with water. Take 18 grams for every 1 mole. And, oh geez, I don't remember what I did as my number. Gotta get my calculator. Told you guys I'm not good at mental math. 90 divided by 18, 5. Five moles of, oops, not copper sulfate. Did anyone catch me? That's 5 moles of water. More important. All right, so now we've determined the number of moles of water and write the chemical formula of the hydrate. Well, in this case, it's very simple. for every 1 mole of copper sulfate, I have 5 moles of water. So my formula would be CuSO4 times 5H2O. And this would be the chemical formula for that question. I'm going to do a real question here now that I took off the AP test questions. So when a 3.22 gram sample of an unknown hydrate of sodium sulfate is heated, water is driven off. The mass of the anhydrous sodium sulfate that remains is 1.42 grams. The value of X in the hydrate is what? So we are looking for the number that's going to go right in front there. Okay, so I'm going to do the same exact steps. First off, I know that the whole the whole hydrate with water weighs 3.22 grams, but it only weighs 1.42 grams after I've heated off the water. So I'm going to subtract 1.42 grams. So that's 3.22 minus 1.42. That's 1.8 grams of water, right? By subtracting the current weight of the hydrate with the weight with the water, I know the difference would be the weight of the water. Okay, now I'm going to convert everything to moles. So I know that hydrate weighs 1.42 grams, and I'm going to divide it by its molar mass, and its molar mass is 142 grams for every 1 mole. So that gives me 1.42 divided by 142, 0.01 moles of the sodium sulfate. I'll do the same thing with the water, 1.8 grams, and it's 18 grams per 1 mole, and that gives me, 1.8 divided by 18, 0.1 moles of Na2SO4. All right, now I don't get a nice number to come out for my moles of sodium sulfate, so I'm going to do the exact same thing I did with my empirical formula questions, right? I'm going to divide by 0.01 moles, and I'm going to do it because it's the lowest factor, right? I'm going to do the same thing here, 0.01 moles. And that's going to give me, for every 1 mole of sodium sulfate, the hydrate, I'm going to get, is it 10? Yeah, 10 moles of the water. So going back to my question, for every 1 mole, what am I going to get here? I'm going to get 10. So the answer was D for this question. Okay, I'll do one more. This is an open-ended one. A 15.67 gram of hydrate of magnesium carbonate was heated without decomposing the carbonate to drive off the water. The mass was reduced to 7.58 grams. What is the formula of the hydrate? So I'm just doing the exact same process. I have 15.67 grams of the hydrate. When it was heated off, it weighed 7.58 grams. So if I subtract those, I should get the mass of the water, 15.67 minus 7.58. I get 8.09 grams of water. Okay, so now I'm going to take the molar mass of those. So I get 7.58 grams of the magnesium carbonate, and I am going to divide it by its molar mass, which I have written down right here. That is 84.3 for every 1 mole. That gives me a moles of 0.089 moles of the magnesium carbonate. I then also will do it for water. I have 8.09 grams of water. I divide it by its molar mass of water, and that's going to give me 0.449 moles of water. Okay, at this step, I am going to take the lowest factor of moles and divide both of them by it. This is 0.089 in this case. I should get 1 mole of magnesium carbonate. For every 1 mole of that, I get 5 moles of water. Okay, that's my ratio. So what would be the formula? Well, I'll have 1 mole of MgCO3 and 5 moles of, 5 moles of water. I'll just write it like this. And this would be my formula for that. So that was pretty quick. If you feel like you need more help, just let me know. We can do it step by step and I can go a little slower. But this is how you solve for hydration analysis questions.